this video, we will be talking about AM power distribution. So in radio transmission, the AM signal is amplified by a power amplifier. Total transmitted power, or denoted as P sub T, is the sum of the carrier power of P sub C and the power of the two sidebands, denoted as PLSB for the power of the lower sideband and PUSB, the power of the upper sideband. So in mathematical equation or expression, we will have a formula for the total transmitted power P sub T equal to P sub C plus P LSB plus P sub USB. So this is the total transmitted power in radio transmission. The power in the carrier and the sidebands can be calculated by using the power formula P is equal to V squared over R. EC and EM are the peak voltage or the peak amplitude voltage of the transmitted signal. In computing for the power of a transmitted signal, we are going to use the RMS value of the voltage. So, kaya nabago yung formula dito kasi in order to convert voltage or peak voltage into RMS, we use the formula V peak over square root of 2. So this will be the formula for the carrier power, the lower sideband, and the upper sideband power. So they are equal. Now if we are going to manipulate these formulas, the carrier power will have a formula equal to this one. E sub C quantity squared over 2R. For the sidebands, that will be EM quantity squared all over 8R. If you recall the formula of EM, this can be equal to, okay, so EM can also be equal to MEC. So if you are going to replace EM with MEC, the formula for the lower sideband and upper sideband, or let's just say that is power of the sideband, this will be equal to M squared EC squared divided by 8R. So if you're going to factor out your denominator to have a factor of 2R, we can do that. So this will be equal to M squared EC squared all over 4. So we factor out 4 para matira is 2R. So looking back at the simplified formula of your carrier power, that is equal to EC squared over 2R, which is also equal to this one. So we can replace EC squared over 2R with PC now. So the formula for the sideband is equal to M squared, okay, M squared P sub C over 4. So we can also use this one if we are only given the modulation index and the carrier power. So for further manipulations of the total power formula, okay, so we replaced EM just like what we did on the last slide. So for this one, we replace EM with MEC. So that's what we did here. And then we came up with this formula or equation. So we factored out EC squared over 2R, which is here. And then we are left with 1 plus M squared over 4 plus M squared over 4. So if you are going to recall the formula for your carrier power, that is equal to EC squared over 2R, which is equal to this one, what we factored out, then the formula for the total power will be equal to PC times the quantity 1 plus M squared over 2. So this is another formula to get the total power if we are given, again, the modulation index and the carrier power. Okay, but if we are given the amplitude or the voltage of the signal, then we are going to use this formula, voltage and your resistance. Okay, So these are the different formulas that we need to remember in solving for the different power distributions. Okay, so let's have an example to further understand the power distribution. So if the carrier of an AM transmitter is 100 watts and it is modulated 100% or M is equal to 1, what is the total AM power? So first, before natin malalaman kung ano yung gagamitin natin na formula, we are going to write the given parameters. So we have your carrier power here, or that is your PC, equal to 100 watts, and your modulation index, that is equal to 1. So this is what we are going to use in solving for the total power. Since we are given a modulation index and the carrier power, yung gagamitin natin na formula for PT or the total power will be equal to PC times 1 plus M squared all over 2. Okay? So, ang gagawin na lang natin ngayon is to substitute these values or given parameters dito sa ating formula. So, we will have total power equal to 100 multiplied by 1 plus 1 squared all over 2. And this is equal to 150 watts. So, the total power is 150 watts. Next example, for a 70% modulated 250 watts carrier, the total power in the composite AM signal is, so again, it is asking us to solve for the total power of the composite AM signal. So given 70% modulation. So yung modulation natin is 70%, which is equal to 0.7. And then, the carrier power, PC, is equal to 250 watts. So, again, ang gagamitin natin na formula will be PC multiplied by 1 plus M squared over 2. So, if we are going to substitute the given parameters to the formula, that will be equal to 250 times 1 plus 0.7 quantity squared divided by 2. So, solving this on your calculator. So, you can pause this video and then type this on your calculator. So, the total power will be equal to 311.25 watts. Okay? So, that is example number 2. Madali lang siya. Parang substitution lang. If you know the formula. So, an AM transmitter has a carrier power of 300 watts. The percentage of modulation is 85%. So, calculate A, the total power, and B, power of one sideband. So, given muna tayo. Given natin is the carrier power PC, that is 300 watts. The percentage of modulation is 85% and that is equal to 0.85. So, solution natin, letter A, calculate the total power. So, since given ulit tayo ng M and PC, gagamitin ulit natin si PC times 1 plus M squared over 2. So, substituting the given parameters to the formula, that is equal to 300 plus 1, 300 times 1 plus 0.85 squared divided by 2. So, the total power is equal to 408.375 watts. So, that is letter A. How about your letter B? Power of one sideband. So, if you recall, the power of one sideband kanina, given tayo ng M and PC, that will be equal to M squared PC over 4. Okay, so, substituting the given parameters, so that is equal to 0.85 quantity squared times your PC, that is 300 divided by 4. So, the power on one sideband now is equal to 54.5 0.1875 watts. When the antenna impedance is known, so yung R natin is known, the output power is easily calculated by using the formula PT is equal to IT squared over R. Yung IT natin is equal to IC times the square root of 1 plus m squared over 2, where IC is the unmodulated carrier current. Okay? So if we are given the unmodulated carrier current and the impedance, ito yung gagamitin natin na formula to solve for the total power of the composite AM signal. So let's have formulas for this one. Okay. The total output power of an 85% modulated AM transmitter whose unmodulated carrier current into a 50 ohm antenna load impedance is 10 ampere is, so the problem is asking us to compute for the total power. So ano ba yung given natin? Can we use the formulas na ginamit natin for the previous examples? So let's see. So we have an 85% modulated AM carrier. So our modulation index is 85% and that is equal to 0.85. Whose unmodulated carrier current is 10 amperes. So that is your IC. 10 amperes into a 50 ohm antenna load impedance. So, yung R natin dito is 50 ohms. So, given tayo ng M, your IC, and your impedance. So, ang gagamitin natin na formula is what we have discussed ito. Si PT is equal to IT squared over R. But first, we are going to compute for IT. So, the formula for IT is this one. IC times the square root of 1 plus M squared over 2. So, solution natin, our PT is equal to IT squared all over R. So, first, compute natin si IT, which is equal to IC times is the square root of 1 plus M squared all over 2. So, if we are going to plug in the values, the given parameters dito sa ating formula, we will have an equation of 10 times the square root of 1 plus 0.85 squared divided by 2. And IT now will be equal to 9.2804 amperes. Okay, so ito ngayon yung ipa-plug natin dito sa formula of our total power. So that is 9.2804 squared divided by R, our impedance, that is 50 ohms. And computing for the total power, that will be equal to PT is equal to 1.7225 watts.